Hello, everyone. Mr. Minnick's my name. Math is my game. Today in my Algebra 2 class, it's Pi Day. You might notice the date, March 14th. Personally, I find it offensive when people say that pi is 3.14 because that's really not what it is. But anyway, nonetheless, it's Pi Day, so happy Pi Day to everyone who cares. Today, the lesson is going to be over solving rational equations. So my Algebra 2 class, we've been into Chapter 8 now for a while. Chapter 8, we said, is about fractions. And in 8.4, we looked at simplifying rational expressions by factoring and canceling. And in 8.5, we added and subtracted rational expressions. So the stuff from the last section is going to be necessary to further this lesson today. So solving rational equations, Chapter 8, Section 6. If you're writing down a title, I'd write down 8.6, Solve Rational Equations. The key vocabulary, cross-multiplying. Cross-multiplying is something that's used when you solve proportions, and that's really the big idea. The big takeaway from today's lesson is the desire, the goal, the task, the chore is to try to get a proportion. Try to get a proportion. If you don't remember what a proportion looks like, we'll talk about them here in a minute. It's a comparison of two quantities by division, and it's an equality of two quantities, actually. So a proportion is essentially going to be a fraction equal to a fraction. Not a number plus a fraction equal to a fraction, but a fraction equal to a fraction. That's what a proportion is going to look like. So that's what we're going to try to do, and then we might be able to use cross-multiplying, or there might even be another trick that's pretty cool that's going to save some time, and we'll talk about that. Before the lesson's through, we also need to talk about extraneous solutions and what those are. We ready? Good. Let us begin. You can use cross-multiplying to solve a rational equation when each side of the equation is a single rational expression. So what I've got here before you is this proportion. Would everybody agree that we have a fraction on the left and a fraction on the right? Looks like a proportion. So in our proportion, we have x divided by SpongeBob SquarePants equals Ed Bassmaster, otherwise the Just Look At It guy, divided by Kool-Aid Man. Okay? So what your knowledge of proportions probably is this. You find the cross product. So the cross product is going to be x times Kool-Aid Man. I can't draw Kool-Aid Man. This is going to be crazy. X times Kool-Aid Man is going to equal the other cross product, which is SpongeBob SquarePants multiplied by the Would You Just Look At It guy. Would you just look at it? Right? I know this is kind of obscure, well, what I got going on here, but everybody remember proportions, solving them, cross-multiplying and all that? Okay. Well, one trick that nobody's ever taught you is that on a proportion, you can exchange any component of a proportion by moving it along a diagonal. If you could imagine a diagonal line here and a diagonal line here, any part of the proportion can essentially slide across that diagonal. You with me? So what if we wanted to solve that proportion that we have? What if we wanted to solve it and get the x all by itself in the upper left corner? What would have to happen? What would we have to do? We don't want an x over SpongeBob, so we want SpongeBob out of there, right? So where's SpongeBob going to go? Up to the Would You Just Look At It guy, right? Okay, so SpongeBob's going to slide up here. So we could say then that x equals Would You Just Look At It times SpongeBob over Kool-Aid Man. Does that make sense? Okay, so that's if we solve that particular thing for x. Let's go ahead and look over here for a minute. And let's go ahead and solve that this time. This time let's solve that for SpongeBob. So if we're solving it for SpongeBob, SpongeBob has got to be in the top, or the numerator, as we should call it, all by itself. So what's going to happen? SpongeBob over X. SpongeBob up here by this guy. Okay, and then what? Bring this guy down here. Oh, down here. Okay, because that's a diagonal. Okay, and then what? We want SpongeBob by himself on that side. So we could have X after Kool-Aid Man, or Kool-Aid Man's going to go up here, right? Or here, right? On the diagonal, right? So SpongeBob would equal X times Kool-Aid Man divided by, would you just look at it? Right? So far, so good? All right, let's try a couple more. Let's go down here. Let's solve that for would you just look at it, guy. Would you just look at it, guy, is going to equal what times what over what? Kool-Aid Man goes with X. So would you just look at it equals Kool-Aid Man times X over SpongeBob, right? And lastly, but not leastly, what if we were solving for Kool-Aid Man? What's Kool-Aid Man going to equal? Well, let's see where everything's got to go. When we're solving for Kool-Aid, he's got to go to the top, right? Not to the top right, but to the top, correct? To the numerator. So Kool-Aid Man will go up here. Where's X going to go? Below this guy. And what about SpongeBob? Up and over. Does that make a little bit of sense? Okay. So that's kind of obscure. Let's try to solve something like this. Let's try to solve X over 5 equals 3 over 5. Solve something like that. So this is example 0.1. So you know that you're supposed to cross multiply, right? So we find the cross product. X times 5 is 5x. And we find the other cross product, that's 3 times 5. That's 5 times 3, which is, that's what, 15? So we could go ahead and divide that by 5 and divide that by 5. So x is equal to 3. Interesting. Interesting. Any questions about that first one? Any observations about that first one? Too easy? Okay. Well, hold that thought, because we're going to do another one just like that one. But this time, we're going to go example 0.2. We're going to solve 17 divided by 2x is equal to 17 divided by 3. Okay? So to solve a proportion, we've got to cross multiply, right? So 17 times 3 is 51. And 2x times 17 is going to be 34x, right? So I'll have to go ahead and divide by 34. And so x is going to equal, now I think 51 and 34 are both divisible by 17, if I'm not mistaken. They're both divisible by 17, so that would equal 3 divided by 2. I want to try another one like example 0.2, but maybe a little bit easier so we can see this more clearly. See if I can group all this together and sandwich that down. Try example 0.3. Example 0.3, solve 100 over 2 equals 100 over x. So we have to cross multiply to solve, right? That's what they tell you. That's what they tell you. So 100 times x is 100x. 2 times 100 is 200. So then we would have to divide by 100. Divide by 100, so x equals what? 2. Does anybody notice anything interesting about these equations that's going on? You could have canceled out the stuff, right? If we look over here at example 0.1, notice the denominators. What's so special about them? They're identical, right? What did our answer end up being? X equals 3. If we forget about our denominators and just kind of pretend, well, those are going to cancel out, we're done. We don't even have to do anything else, right? So if the denominators are the same, we can kind of disregard them and just set the numerators equal. Do you see what happened in example 0.3? The similar thing, but with the numerators, right? In example 0.3, if you look at this, you can say, well, the numerators are the same, so the denominators are, and x equals 2, and you're done. You don't have to cross multiply if the numerators are identical or if the denominators are identical. Does that make sense? Okay. So let's try this one then. Example 0.4. Solve. X plus 5 over 3,000 equals x equals 2x plus 1 over 3,000. So do I really need to cross multiply to solve all this? No. What smaller equation can I now write? X plus 5 equals 2x plus 1. Awesome. And then when we solve that, I guess we'll subtract x from both sides. So we'll have x plus 1 equals 5. And then we'll go ahead and solve that by subtracting 1 from both sides. And so our solution is that x is equal to, is that going to be 4? Okay. So how do you feel about something like that? Does that make sense? Cool. That's one trick that you're going to want to look out for. That's one trick. Here's a sneak peek into the future. In the future, you're going to see something like this. Solve x over x squared minus 9 equals 2 over x plus 3. So from what we've been doing the last week and a half in class, you should recognize that the denominators are pretty close to each other. Yeah, you should recognize that specifically this denominator is really a difference of 2 squares. And I hope by now you get the fact that you're factoring this stuff. X isn't going to equal 2, but our denominators are close. This is going to be x plus 3 and x minus 3, right? So our denominators are almost the same. Well, what we've got to do is we've got to modify this equation, right? So we got to multiply it by what? X minus 3 over x minus 3. Does that make sense? Okay, so that's kind of where we're going to be heading today. Does that make sense? I hope. All right. So if we finished this, if we completed this thought then, at this point moving forward, we can go ahead and disregard our denominators. So then x is going to equal, yeah. Why was it a minus, not a plus? Because we were trying to match up with that. We want these denominators to be identical. And this already had the x plus 3 in it. Good question. So we're going to have to go ahead and distribute this 2 through, so that's going to equal what? 2x minus 6. And so when we solve that, we'll get x equals 6. Yeah, question? Yeah. I could go up a little bit. I could go up a little bit more. So couldn't we take a square root? You know, people try to look for shortcuts. We did what we did last week for a reason. You know, people want to try to take the square root of this. There's no property that says we can do that. It doesn't work that way. Square x and square 3. So you want to square this and square that. Yeah, you can't do that either. That's an illegal move. Yeah, that's kind of like going 70 in a school zone. You don't do that. Yeah. Good question, though. Good question. The whole point of everything that we've been doing leading up to this point, remember 8-4, factor and cancel? I don't want to say anything about the quiz from yesterday, so I'll say very little about it. But anyway, I think people miss the boat. It's factor and cancel. Factor, 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 factor. That's why we went from chapter 4 to 5 to 8, because it's all about factoring. You have to be good at it. You have to factor. You can't just make up your own rules on the fly. You can't just say, well, let's just square this and multiply this by -3. You can't make up stuff like that. Okay, but that's a good thought. But we can't go making up rules on the fly. We can't be like those people out in Hollywood that pay somebody $15,000 to make us on USC's dance team either, right? Because it just doesn't work that way. So, all right. So here we are, example 1. Oh man, would have been nice if our denominators were identical, but they're not. But wait, what about our numerators? Aren't they pretty close? Multiply by 3/3, because we got to use the multiplicative identity, right? So we can get our numerators to equal 9. So if we multiply this by 3/3, we're going to end up with 9 over, now we got to use the distributive property. Don't forget all your sound mathematical rules. 3 times x is 3x. 3 times the 1 is plus 3. So we have 9 over 3x plus 3 equals 9 over 4x plus 5. So now our numerators are identical, aren't they? That's awesome. Look at that. So what's our new equation then, our smaller equation that we can write? Yeah. Boom, there it is. 3x plus 3 equals 4x plus 5. And we'll go ahead and solve that. So we'll have to what? Subtract 3x from both sides. That's going to give us 2x. We'll have to go ahead and subtract 5 from both sides. So 2x is going to equal, is that -2? And so x is equal to, yeah. How'd I get 2x? That's a good question. That should be x, shouldn't it? That's my bad. I'm sorry. I was just so excited about how this one was shaping up. So that's supposed to be x equals -2, and that's it then, right? Is that it? Cool. Any questions, comments, concerns about this so far? Seems pretty easy if you have a proportion, right? If you have a proportion. 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 What if you don't have a proportion? You want to make one. One thing I need to show you, I mentioned this before, I'll say it again. I kind of put the cart before the horse with this lesson. We haven't looked at graphing these things yet. But some of these graphs, when we graph them, they're going to look like this. Woo! And sometimes something like that is going to be set equal to a line, which might look like that. Woo! So suppose we had an equation. Remember how to relate an equation to the graph. The solutions are the x values where the graphs meet, right? So how many solutions could that particular scenario offer us? How many? Solutions would be any place where the lines intersect. Looks like the lines intersect here. That might be one solution, right? And over here, that's how many solutions then? 2. So these could have 2 answers. What if we had a situation like this, though? What if this line looked like that? How many solutions might we have? So it's possible there's no solution, right? What if our line looked like this? How many solutions might we have? Just 1. Everybody with me so far? Good. Okay. I want to look at number 2. Cut it out, put it on a brand new page. So if we look at this one, are our denominators identical? Are our denominators identical? No, they're not. So we can't do that trick. Could we just multiply the +3 by -3 or make the -3 positive? Can we just do that? No, not allowed to. So moving forward on this, cross-multiplying probably is going to be your best option. Yeah, question. Wouldn't this be no solution? Oh, there's going to be a solution. And when you have something like this, it wouldn't really be easy to get those to equal each other, would it? And it really wouldn't be super easy to get those to equal each other either, would it? So we're pretty much going to have to cross-multiply now. So sometimes you're just going to have to suck it up, buttercup. That's what my wife always tells me. And just cross-multiply. So 5 times the group of x plus 3 is going to equal negative 4 times the group of x minus 3. Sometimes you're just going to have to do it. 5x plus 15 is going to equal negative 4x plus 12. I'm really glad we took a minute and looked at this one. So solving the rest of this then, I guess I'll put all my x's on the left. I'll add 4x. Add 4x. So 9x plus 15 is equal to 12. Go ahead and subtract 15 from both sides. So we have 9x is equal to negative 3. So 9 times 1 is 9, so it's not going to be 1. X equals negative 1/3. Thank you. I'm so glad somebody didn't say negative 3. It's awesome. Just made my day. Just made my day. So we got to divide. So when we divide by the 9, we divide by the 9. So x equals negative 1 divided by 3. And it was reduced too. That's awesome. Good job. Made my day. Good. So sometimes you're going to have fractions for answers, and that's okay. Fractions are fine. This is varsity math. How do we feel up to this point, okay? Let's take a 30-second brain break. Wonder if I could tell a joke. Pi and I. Did you guys hear about Pi and I? Pi and I were having an argument. You know, I is the square root of negative 1, right? And they were mad at each other. If you remember, we talked about these things earlier, right? So I said to Pi, man, you got this all wrong. Can't you just try to be rational? And Pi said, get real. Anyway. So they're kind of now talking about using LCDs. We've mentioned that. We said if the denominators are the same, we can set the numerators the same. If the numerators are the same, we can set the denominators the same. So let's look at example 3. It's multiple choice too. That's awesome. I love multiple choice ones. Rather than just randomly guessing C, I like to actually solve them because I know one of the answers is there. I think it's kind of fun to answer multiple choice questions. I'm going to cover up my choices for now. I don't even care what my choices are. I'm going to see if I can solve this. If you have a proportion, these are easy. We don't have a proportion though. Got to make one, you're right. There's 2 terms here that I think are going to be easier than the other 2 to put together. If we look at these 2 terms, they have uncommon denominators, right? But these 2 terms have the same denominator, don't they? Ooh. So those are probably going to be pretty easy to combine if we know how to add rational expressions. Oh, wait a minute. We did that in the lesson the other day ago. So I could easily subtract 5 over x from this side and subtract 5 over x from this side. I got to be careful. Watch the negatives. Be real careful with negatives. So 5 over x minus 5 over x, that's going to cancel that. And on the left side, I'm left with 7 over 4. Now I had negative 9 over x, and I'm taking away 5 over x. So what's that going to give me? So many over x's. How many over x's? Negative 9, take away 5, I mean. Negative 14, good. Negative 14, okay. The reason I mentioned about the negatives, you got to watch the negatives. I don't know if you know this or not, but this negative sign could go out front here. Sometimes they write it that way. When you're working with a proportion, it's a good idea to attach that to either the numerator or the denominator. Make sure it goes somewhere. Because if you leave it out front, it becomes way too ambiguous or vague, or you might lose it. Does that make sense? Okay. So I'm going to go ahead and put it on that 14 right there. Now, let's think about this. So if my denominators were identical, this would be pretty easy. They're not. If my numerators were identical, this would be pretty easy. They're not, but they're close. We could cross multiply, or we could multiply the left side by -2 over -2 if you want. It's up to you. You want to cross multiply? All right, let's cross multiply. So we cross multiply. This cross product is 7x. The other cross product, maybe you can't multiply -14 by 4. That's okay. At -56, good. Maybe you can. I was going to say double it and double it, but yeah, it's -56. That's an awesome idea. Yeah, just double it and double it. That's how you multiply by 4. Good deal. So we divide by 7. So we think then that x equals what? -8. So let's go back now and check, because it's got to be one of those. And it is, and the right answer was B. The right answer on this one was B. So I'll go ahead and make that full page so we can see that. So again, if we have a proportion, these are easy. If we don't, make one. If you don't have a proportion, make one. I probably shouldn't show you this, but I'm going to. You know, when we have a chapter test over this, there's going to be a calculator chapter test and a non-calculator chapter test, right? There's a command, abracadabra. What's the command that we could use on the calculator to have it solve for our numeric answer? Nsolve. You could nsolve this. It's going to take a minute for that calculator to load. While it does, I should probably remind you about myself. I'm sorry, I'm aging, so I apologize for my shortcomings as a math educator. You know what happens to old math educators, right? They start to lose some of their functions. I promise I won't tell you about the constipated mathematician. Unless you want to know. But I promised I won't tell you unless you want to know. You know why people don't like math teachers, right? Because they have a lot of problems, and they share them with everybody they know. Well, the calculator is stalled. Interesting. So I want to nsolve this one day when the calculator decides to cooperate, when it decides to load. Nobody's going to bite on that one. Nobody wants to know. It's a good thing. It's kind of gross. You want to hear it about the constipated mathematician? He had a problem. You know how he solved it? He worked it out with a pencil. Okay. So we're nsolving. To find that nsolve, you can either bring it up through the menu, or you can actually just type nsolve. So we type N-S-O-L-V-E, left parenthesis, our equation, 5 over x plus 7 over 4 equals, was it -9 over x? -9 over x. And then we got to tell it, let's solve it for the variable, x. Boom, there it is. So let's think about this for a minute. On an upcoming chapter test, you're going to have to graph things. You could use a calculator to graph things. You're going to have to solve things. You could use a calculator to solve things. In my mind, my feeble mind, I'm thinking a calculator chapter test is probably an opportunity for just about everybody to do okay, isn't it? I would hope. Anyway, okay, so let's move on. Let's look at example 4. Remember, I said it 3 times. I'll say it again. If we have a proportion, these are easy. If they're not, we need to get one. Do we have a proportion? Not exactly. So you need to be able to see these things as terms. There's a term here, this 1. That 1 really screws up the whole problem. But you know, that 1 and this 3 over x would probably be pretty easy to put together, wouldn't they? Rather than having a 1, I'm going to scratch that 1 from the record and I'm going to rewrite it. See if anybody can read my mind. I'm going to try to impart onto you with telepatheticness. Wait a minute, I just called myself pathetic. Mental telepathy. What are you going to change that to? Not 1x. Good try, though. X over x. Yeah, so that's going to be x over x, right? Okay. Now, which side of the equation you decide to put this on, that's entirely up to you. But do you see that minus in front of the group of 8 over x minus 5? I really don't like that. Personally, I hate dealing with negatives. So what I would do is I would take this entire term, which happens to be negative, and I would have that term go across the drawbridge. It's going to have to pay a toll. And when it does, it's now going to be positive 8 over x minus 5. Does that make sense? Okay. So then to bring this 3 over x over to the left side, then I'm going to be doing what with it? Subtracting it, right? So I have x over x minus 3 over x. What is x over x minus 3 over x going to equal? X over x minus 3 over x. X over x minus 3 over x. What's that going to equal? What's that? Well, it's going to be something over x, right? X minus 3 over x. There it is. Nice. X minus 3 over x. Okay. So now we have a proportion. If our numerators are identical, it's not that bad, but they're not. If our denominators are identical, it's not that bad, but they're not. So what should we do? How do you solve proportions? Cross multiply. Do you see what's coming in your near future? A binomial times a binomial. Oh, that's foiling. That's going to mean a quadratic. Oh, no. You mean we're going to have a quadratic? Yeah, you're going to have a quadratic equation. X minus 3 times x minus 5. X minus 3 times x minus 5. That's going to be what? X squared minus 8x plus 15. And that's going to be equal to the other cross product, 8x. Oh man, I didn't sign up for this. We're out of chapter 4. We shouldn't have to solve quadratic equations anymore. We're out of chapter 5. We shouldn't have to solve polynomial equations anymore. So we'll go ahead and subtract 8x from both sides. So we're going to have x squared take away 16x plus 15 is equal to 0. So we got to solve a quadratic equation, and we talked about many ways to do that. We said you could solve that by factoring. We said you could solve that by factoring. We said you could solve that by factoring. We said we could solve that by factoring. We said we could solve that by factoring. So you're looking for factors of 15, right? That add up to 16? So what are we going to go with? 1 and 15. And I guess that's going to be an x and an x, and we got to figure out our signs. It's a minus on the in the middle. It's a plus on the end. Plus on the end means they got to be the same. Minus in the middle means both sides got to be negative. The zero product property comes into play. Each factor gets set equal to 0. Each factor gets set equal to 0. So our solutions are that x equals something and x equals something. X equals 15 and x equals 1. I wonder if both of those are the answer. Earlier we saw that there could be two answers sometimes, right? Now, I do need to caution you. NSolve is only going to give you one answer. That's the problem that I have with NSolve. It only gives you one answer. That's why I show you more than one way to the Eastwood Mall. That's why I show you that there's more than one way to solve a problem. So we had 1 minus 8 over x minus 5. 1 minus 8 over the group of x minus 5. That was equal to 3 over x. We're going to solve that for the variable x. And my calculator tells me that one of my answers is 1. Well, there's two answers, though, and we only got it half right. That's 50%. That's not doing very good, is it? So another thing that we could do if we used the calculator is we could solve by graphing. We could graph that first expression, 1 minus 8 over the group of x minus 5. And then we could graph the second function, which was it 3 over x? 3 over x? So how many times do those graphs appear to intersect? Menu, zoom, maybe I better zoom out. Maybe I better zoom out. Oh, they do intersect twice, don't they? Guess where? When x equals 1 and when x equals 15. Questions, comments, concerns, short debates about this. We need to talk about rappers. Not like Snoop Dogg and Tupac. Not that kind of rapper. The other kind of rapper. You ever get a gift? I don't understand gifts. I really don't. Like, especially when you get something new. Because when it's given to you, they put it in a wrapper. You already know what it is because you asked for it. Most of the time, some of the time, right? You know how big a shoebox is, so you know if you got a new pair of shoes. And then there's a box that goes with it. Anyway, the point is sometimes there's stuff that we don't need. When I want a new pair of shoes, I don't want the box, unless it's a really nice pair of Jordans, and then I might save the box and store them in that. But most of the time, I don't want the box, and I don't want the wrapping paper. I just want the Jordans. What the heck is he talking about? You'll see in a minute. You'll see in a minute. Okay, so a couple things to note about this last example we're looking at today. The denominators, oh, we don't have a proportion, so we got to get a proportion. Dang it. And the denominators of those terms on the ends, they're kind of close, but they're not the same. Whoop, that was supposed to be a box. Let's try that again. These denominators are kind of close, but they're not the same. I can't just magically change the x minus 3 and an x plus 3, although some people try to make up their own rules. It doesn't work that way. Oh, but if I multiply the one by one thing and the other by the other thing, then everything's going to have the same denominator, isn't it? So let me cover up this solve here so I have some space to work with. So if I multiply this by x minus 3 over x minus 3, and this by x plus 3 over x plus 3, then all of my denominators are going to be the same, because this x squared minus 9 is really, awesome, because it's really x plus 3 times x minus 3. It's really x plus 3 times x minus 3. So this is not horrible. This is not horrible to work with, but I do have a little bit of cleaning up to do, so to speak. So my denominators are all the same now, so I could go ahead and kind of disregard all the denominators now and just look at everything that's in the numerator. So let's see, this is 6x plus 18. That's going to equal 8x squared minus, let's see, that's 4x times x, that's minus 4x squared. Negative 3 times negative 3 is that plus 9? Or, wait a minute, negative 4x times negative 3, is that plus 12x? Plus 12x, okay. All right. All right. Doing good. I'm doing good. Everybody follow what I did there? I hope. Okay. Cool. So I have some like terms that I probably ought to try to combine. So that's going to be 4x squared plus 12x equals 6x plus 18. I still got some like terms because this 6x and this 12x can go together, can't they? I'm going to go ahead and put everything on the right side of the equation, if you don't mind. So I'm going to leave my 4x squared there. So I guess I'll subtract 6x from both sides. So that's going to be 4x squared plus 6x. And then I want that 18 to join everything. So minus 18. Minus 18. So minus 18. And all that's equal to 0, I believe. I believe all that's equal to 0. 4, 6, and 8. Can we do anything with 4, 6, and 8? Not a square root. Divided by 2. Nice. We factor out a 2. Good. I'm glad that people brought their A games today. I'm so happy. So we divided 2 out. So this is 0 equals 2 times 2x squared plus 3x minus 9, right? This 2 that we factored out doesn't really impact our solution set. So let's see if we can factor this. Let's see if we can factor this. If I plug in a 9 here, that's going to give me 18. That's too much. If I plug in a 9, if I plug in the 9 over here, I'd have to do a 1 here, and that'd be 7 or 11. That's not going to work. So 9 and 1 can't work. So I guess I got to do what? 3 and 3? Will that get it done? 3 and 3. So this outer product is going to be 6x. This inner product is going to be 3x. So I want 6x and 3x to add up to 3x, right? So I need to make whatever is going to give me the 6x positive. So I'll put a positive here. And I want the other one to be negative then, so I'll put a negative here. Okay, so we're getting there. 0 product property. 2x minus 3 equals 0. X plus 3 equals 0. So 2x equals 3, x equals negative 3, and then I divide. So I get a fraction and a whole number. I get x equals 3 over 2, and I get x equals negative 3. But I have some wrapping paper. I do. What do you do with wrapping paper? Throw it away. One of those answers isn't really one of the answers. In math class last week, we said that something's bad. Anybody remember what we said is bad? 0 being where? In the denominator of a fraction. Division by 0 is bad. So looking back at the beginning problem, I know it's been a long time since we've been there, but looking back, if we plugged in a negative 3 right here, we'd have negative 3 plus 3 in the denominator. What's negative 3 plus 3? 0. And we'd have division by 0. That can't happen. So the solution that gives us a 0 in the denominator is not a solution. It's wrapping paper, and we're going to throw it out. In mathematics, what that's called is an extraneous solution. We did really good algebra. We got a really nice gift. Somebody spent a lot of hard time wrapping it. And the wrapping paper's there, but we don't need it because it's not beneficial to us. That solution is a solution, but it doesn't satisfy the original equation. The wrapping paper doesn't make me happy. I don't want the wrapping paper. I can't wear the wrapping paper to protect my shoes. To protect my feet. You know what I meant to say. It's been real. It's been fun. I hope you learned something. I'm really glad for everybody who brought their A games. Nice job. Happy Pi Day. See you next time. Good.